Hello, and thank you for stopping by the CCX Technologies booth at the 2023 ACI Cyber Rodeo. I'd like to thank the U.S. Army PEO Aviation for the invitation and the opportunity to connect with everyone over these next couple of days. My name is Matt Bartolotta, and I'm the Director of Business Development for Cybersecurity with CCX Technologies. CCX is a Canadian-owned small business founded in 2017 with headquarters in Ottawa, Ontario. Our U.S. presence includes a maintenance depot in New Jersey, a registered LLC in Delaware, and a sales office in Texas. CCX specializes in the design and development of a wide range of cybersecurity solutions for the aerospace, OEM, and military mobile platform markets. Our System X software and suite of accompanying aerospace certified hardware systems deliver a cutting-edge solution for monitoring, detecting, and alerting on nefarious and anomalous activity onboard aircraft platforms. CCX is also developing solutions for zero trust and is positioned to rise as a leader in this important segment of the cybersecurity market. We've prepared a demonstration video for you to highlight our current certified avionics intrusion detection system for aircraft platforms. This demonstration shows the effect of an ARINC 429 data-based cyber attack on board an aircraft, how the avionics IDS can flag this type of event, and how our zero trust model could mitigate the risk of similar attacks in the future. It includes live views for air traffic control, the pilot, and the Security Operations Center during the event. Please enjoy the live demonstration with our Senior Technical Program Manager, Ms. Eero Pittiglu, as she showcases the System X software and accompanying hardware that can help improve the cybersecurity posture on board the aircraft. Thank you.
Hi everyone, welcome to the CCX Technologies demo. We're going to show a real-time cyber attack. More specifically, in our demo there is a real equipment that is sending GPS data, while at the same time an injector is injecting anomalous data into the data bus in order to trick the aircraft to think it's somewhere else from where it actually is. Overall, what we're trying to do in these 6 windows, we're trying to show the cybersecurity evolution. Starting from the right, we present the past. We show how the system behaves under cyber attack when there is no cybersecurity solution intrusion detection system. In the middle, we show how the system behaves with our current CCX technology cybersecurity solution and intrusion detection system. This solution is deployable, is available, it's be used by various customers. So this represents the present. And then on the left, this represents the future, where shows how the system behaves with the new technology that CCX is working on, Zero Trust, and it's part of our roadmap. Before I go through these 3 scenarios, I would like to provide a little bit more information about the layout. So on top, what you see is the simulated air traffic controller display, what they see on the ground. In the middle, we have simulated the instruments that the pilot will see at the cockpit. So we have instruments that show airspeed, heading, vertical speed, GPS data, etc. And at the bottom, we have the dashboard that they see at the Security Operations Center SOC at the ground. So let's start again from the right. Here the system is under cyber attack, as was mentioned, with the anomalous GPS data, but there is no way for the system to detect and alert the crew that something is wrong, that there is a cyber attack. In the ATC display, they see that the plane is jumping around. However, there is no way for the pilot to know about that. They are looking at the instruments on the aircraft, the cockpit, and there is no indication that something is wrong. So the same is happening at the SOC center. They think that everything is okay, even though that the system is under attack. Moving in the middle, here our CCX Technologies cybersecurity solution is detecting the cyber attack. and there is an alert that's coming up to notify the crew. So when an alert in the ADC, as you can see in red here, then we have an alert at the cockpit, cyber event detected, and then alerts are coming up at the SOC center. And now I'm going to explain how the CCX cybersecurity solution and intrusion detection system work. So our appliance can be installed in any kind of platform, in the sea, land, air, and space. It can be connected to existing networks such as IP networks and MIL-standard 53, AAR 429. Once it gets connected, you start getting data, collecting data from all these different interfaces that comply to different protocols. Then this data will be converted to a common data format that's been developed by CCX. The converted data then, they will go to the IDS system where they will be processed by the algorithms. The algorithms will try to detect anomalies, and in case there is an anomaly, they are going to raise an alert to notify the crew. Few examples of the algorithms that you could have in the system are the following. You could have algorithm that is checking errors with regards to the protocols, such as parity bit error. Or you can have an algorithm that is checking any data, unexpected data on the interface. Or you could have an algorithm that is checking the data itself. So the CCX Technologies solution appliance that is installed on board, it can be connected remotely to a ground server. The ground server can be in a hardware at CCX facility or a customer facility or in a cloud environment. So the operator on board can push all the data like raw data, converted data, alerts, configuration settings, can push all its information to the ground server. There, the team can review the data and provide a further analysis, real-time or post-mission, analysis that is going to include information about threat response, mitigation plan, alert ranking. So this SOC service can be provided by CCX and can be offered to our customers. In order to explain further how the IDS system works, we can move to the GUI. So this is what the operator is going to see when we are connected to our system. This is the GUI that comes up. So if we go under security, we're going to bring up the IDS, and here is the algorithms. So our systems comes with a baseline starting point for algorithms. However, there is also a development platform for the customers to develop their own algorithms based on their needs and the anomalies that they want to detect. So we can provide training to the customers to develop their algorithms, or we can do that on their behalf. In this particular demo, we are running one algorithm which is checking the rate of change. And here you can see the platform. This is the platform that you can go and make updates, and you can write code to your algorithm. Now there is one more entity in our system called rule. The rule gives us the opportunity to run the same algorithm on multiple parameters. In this case, we're running the algorithm for rate of change on two parameters, latitude and longitude. So I can go here to show you the rules. As I said, we have two rules that they're calling the same algorithm, and I will open one just for the example. It says here that is running that on the longitude parameter. And in that way, it can see that these two parameters, they exceed a specific threshold, so our system raises an alert to alert the crew that something is wrong in the system and it's under cyber attack. And now we're moving to the left. In this case, our system represents the future here. We have the new technology the CCX is working on, Zero Trust, is part of our roadmap. So Zero Trust not only detect any cyber attack that's taking place in the system, but also protect the mission from any interruptions. In the traditional security models, once you get access to a network, you are free to do whatever you want. In Zero Trust, it's not like that. No one is trusted until it's verified. So you need to establish a level of trust, and then the system will make a policy-based decision to decide what kind of functions you are allowed to perform in the network. So overall, the main principles of the Zero Trust are the following. On the data source, we have the signer that would sign the data with multiple signatures associated with multiple certificates. We would have a certificate associated with the device itself that's sending out the data, or with the software version that is running on the device, or with a specific crew member. Once this data is signed and they are going to the receiving end, then we have the verifier. The verifier needs to verify the signatures. And in case one of the signatures is missing or failing, then it's going to identify the level of trust. And as we mentioned, the system will then need to make a policy decision on what to do with this data. In this particular case, the signature associated with invalid data has failed. So the system has made a policy-based decision to reject the invalid data. So whatever we see in our screens on the top and in the middle, these are only valid data. At the SOC center, they can see that there is an alert, that there is a cyber attack. However, our mission is not being interrupted. And this is the new Zero Trust security model that we're working on, and it's part, as I mentioned, of our roadmap. Thank you for watching our demo.
Thank you for taking the time to watch our live demonstration. CCX Technologies is committed to supporting the U.S. Department of Defense as it faces new requirements and policies for ensuring the cybersecurity posture on board aircraft, as well as other mobile platforms. We're excited about successfully overcoming these challenges through direct work with the Department of Defense, as well as strategic industry partners. Please contact me with any questions via our booth or at matt@ccxtechnologies.com. Looking forward to hearing from everybody and the opportunity to work together. Enjoy the show.